guys, I'm Goreblaster. I wanted to find out exactly what makes these brand new super fancy cables from the String Source just so super fancy. According to the String Source website, this cable is an ultra-low capacitance cable. Now, capacitance in a guitar cable is actually very important for the following reason. Guitar pickups have what is called an output impedance. Output impedance tells you how much current can be sourced from some electrical system as a function of frequency. Now, what output impedance also tells you is what kind of filter network is going to be formed when that electrical system is connected to other electrical systems. In the case of a cable plugged into a guitar, the pickups combined with the capacitance of the cable form a filter network which actually attenuates various frequencies before it reaches the input of your processor or guitar amplifier. So, in the interest of getting the highest quality recording of our guitar signal when we're tracking at home or in the studio, we should take care that the capacitance in our cable isn't irreversibly filtering out some of the high frequencies from our guitar signal. So, in order to evaluate this cable, I'm going to perform a few tests. I'm going to measure its capacitance and compare this capacitance to another more run-of-the-mill cable. I'm also going to look at the combined frequency response of the combined system of some passive guitar pickups with this cable, and once again compare it to a more standard cable. Finally, I'm going to do some A/B testing, playing the exact same riff, switching back and forth between the two cables, so we can hear exactly what difference the higher quality cable makes. So first, we're going to try and measure the capacitance of this cable. We'll be making all the following measurements with a portable signal analyzer made by Digilent. To begin, I've configured the signal analyzer to perform an impedance measurement. Currently, I have a single 150 picofarad ceramic disc capacitor connected to the analyzer. So as you can see on screen, the analyzer is currently measuring about 150 picofarads. So, let's start measuring some cables. First, I'm going to measure one of the standard cables I have lying around. I won't specify the brand, but this cable is 15 feet long and costs somewhere between $15 and $20 from a major music retailer. Now that I've connected this cable to the analyzer, we can see what it reads. And it looks like we're reading about 575 picofarads. This is the total capacitance of the cable, including the connectors. And here we have the cable from the String Source. This is also 15 feet long and retails for about $85. So indeed, this is significantly less than the 570 picofarads we measured in the other cable. So now let's take a look at what this reduction in capacitance does to our guitar signal. So now we're going to compare the frequency responses of the two cables. In order to do this, I'm going to use the digital signal analyzer as a fast Fourier transform spectrum analyzer. The way this works is the signal analyzer takes the Fourier transform of one of the signals coming in to one of its inputs. The Fourier transform allows us to plot which frequencies comprise the signal that's coming in, so we can actually view the electrical spectrum of the electrical signal from the guitar. So to begin, I'm going to plug my guitar into the standard $15 to $20 cable and run it into the spectrum analyzer. You can see on screen the real-time spectrum of the guitar. If I strum a chord, you can see quite a few peaks show up, corresponding to all of the fundamentals and harmonics of all the notes in this open E chord that I'm playing. If we ultimately want to compare the frequency response of the two cables, we should bear in mind that the height of all of these peaks depends not only on how hard I hit the strings, but also how long we wait between strumming and analyzing the spectrum due to the natural decay of the chord. So, to try and iron out some of these systematics, I'm going to actually average together the spectra of about 30 seconds of continuous strumming of the same chord with the same pick. If I do this for both types of cables, we should have a pretty even comparison. Alright, and now we have a spectrum corresponding to the signal passing through the $15 to $20 standard instrument cable. I've now frozen this trace on screen for future reference. So now I'm going to do the same experiment but using the String Source cable. Okay, so let's compare these two traces. Well, below about 3 kHz, there isn't too much difference in the spectrum passing through the two cables. This isn't necessarily too surprising. given the typical output impedance of a set of guitar pickups and these capacitances on the order of a few hundred picofarads that we're talking about, we'd expect frequencies to start rolling off at a little bit higher than 1 or 2 kilohertz. So indeed, as we pass the 3 kilohertz mark, we start to see a general trend where the red trace corresponding to the string source cable shows peaks that reach 1 or 2 or 3 dB higher values than the trace from the standard cable. This corresponds to more signal strength at those frequencies, which means that those frequencies are better preserved while passing through the cable. The effect becomes very remarkable when we get out above 6 kHz. Here we see differences between the two cables as large as 6 dB across a range of frequencies. So this is where the design of this cable really shines. The low capacitance design of this cable has helped preserve much more energy in all of these frequencies than we saw when passing through the standard instrument cable. So now that we've sort of characterized the electrical properties of the string source cable, let's put it to the test and see if we can hear the difference between the string source cable and the standard instrument cable of the same length. So I can definitely hear a lot more of the high frequencies coming through when I use the string source cable to plug into my Axe effects than when I use the standard instrument cable. So I think I've learned everything I needed to learn about this cable. Indeed, it does have lower capacitance, and this capacitance affects the tone in a non-trivial way. So there we have it. Thanks for joining.